3D problem solving using Pythagoras theorem. Now in the previous topic we studied how Pythagoras theorem can be used to solve a whole range of real-world problems or two-dimensional real-world problems. Well, Pythagoras theorem can also be used to solve problems in 3 dimensions, 3D problems. For 3D problems we will likely have to use Pythagoras theorem more than once, as we often need to create extra right angle triangles to help solve these types of problem. Okay, that said, let's have a look at an example. The cuboid shown has dimensions of 5 centimeters, 8 centimeters, and 3 centimeters. Calculate the length of diagonal AG and give your answer to one decimal place. So we have a diagram and the diagonal AG is shown in green, and we need to calculate the length of AG. So how do we do that? Well, we need to find an expression for AG. Now looking at AG is also the diagonal for rectangle AEGC, and for that rectangle we have the side GC as 3 centimeters, but we don't have the side AC. If we did have the side AC, given that a rectangle has right angles within it, we could use Pythagoras theorem to find the length of AG. So let's mark that in our cuboid. So if we can find the length of AC, then using the length of AC and the length of GC, we can calculate the length of AG using Pythagoras theorem. So we have an expression for AG. AG squared equals AC squared plus CG squared, which is equal to AC squared plus 3 squared, as we have the length of CG. So then the question becomes, how can we find the length of AC? Well, looking at the cuboid again, the length of AC can be found by using the triangle A, B, and C. We have a right angle triangle here again, as the base of the cuboid will be a rectangle, so its angles will be right angles. AB we know is 5 centimeters, BC is 8 centimeters, so using Pythagoras theorem we can work out AC. AC squared equals AB squared plus BC squared, which is 5 squared plus 8 squared, 25 plus 64, which becomes 89. So AC squared is 89. Now we don't need to find the root of this because we'll just be squaring it again in the next step, so we can leave this as is. Now let's go back to our expression for AG. AG squared equals AC squared plus 3 squared. So now we know that AC squared is 89. So AG squared equals 89 plus 3 squared. So this becomes 98. Now we can take the square root of this to find the length of AG. So AG is equal to 9.9 centimeters. So as we can see, we have used Pythagoras theorem twice to calculate the length that we need for this 3D problem. In our next example, we're asked to calculate the height of this rectangular base pyramid to one decimal place. We're given a diagram of the pyramid, and we can see that AE is 18 centimeters, AB is 12 centimeters, and BC is 6 centimeters. We can also see the height as shown in red, and we see that it makes a right angle with the base. Now, even if we weren't given this, we should know the perpendicular height of a pyramid would make a right angle with the base. So we need to find an expression for the height. What will help here is if we mark a point for the base of the height. Let's call that x. As we can see, we have a right angled triangle with AE as the hypotenuse. So the expression for the height could be AE squared equals XE squared plus AX squared. Now we know AE, so that's 18 squared equals XE squared plus AX squared. So if we can find out AX, the length of AX, we can use Pythagoras theorem, rearrange this equation, and work out the height XE. Okay, so how can we find AX? So let's have a look at the base of this pyramid in more detail. The base, ABCD, is a rectangle, and we were told it's a rectangular base. And the point X will be in the center of this rectangle. That means it will be halfway between A and B, and halfway between the points B and C. So we want the length AX. Let's add an additional point here, Y. So we have a right angled triangle AYX. Now we can calculate the length of AX using Pythagoras if we have the lengths of AY and YX. So how do we calculate those lengths? Well, as we said, the point X will be halfway along AB, so AY is AB over 2, and it will be halfway along BC, so YX is BC over 2, and we have the lengths of AB and BC. Okay, so AY is equal to AB over 2, which is 12 over 2, which equals 6, and XY is BC over 2, which is 6 over 2, which equals 3. So AX squared will be AY squared plus XY squared, which is 6 squared plus 3 squared, which is 36 plus 9, which is 45. So AX squared is 45. Now we don't need to find the root. We take this as is and put it into our expression for AE squared. So AE squared was equal to XE squared plus AX squared. So that's 18 squared equals XE squared plus AX squared. Let's plug in the 45. So 18 squared equals XE squared, our height, plus 45. Rearranging for XE, we get XE squared equals 324 minus 45. And then this gives us XE squared as 279. Taking the square root of this gives us XE equal to 16.7 centimeters. So again, we have used Pythagoras theorem more than once to solve a 3D problem. Okay, that's it for the 3D problem solving topic using Pythagoras theorem. As always, the more questions you do, the more problems you do, the more you'll understand how to solve the different types of questions that you'll be asked in an exam. So as always, now it's time for you to go off and practice.